Welcome back. I hope you have experienced that the gradient information was useful to minimize the cost function. Now let's discuss how gradient descent uses gradient information. Gradient descent starts with a random parameter vector w. Then it will use iterations to update the parameter vector. Each iteration, it updates the parameter with the equation on the slide. Take the value of the previous iteration and subtract eta times the gradient to get the new parameter vector. Eta is always positive. Because of the subtraction, we move in the opposite direction of the gradient, thus in the direction of a lower cost. Now what is eta? Eta is a number that determines the size of our steps. The negative gradient tells you the direction and eta is a multiplier. There are two other concepts that you should be aware of, and the first is called an epoch. An epoch means that you have used all objects of the training set once to update your parameters. If you perform the update given in this slide, you have completed one epoch, because remember that j, the objective function, was a sum over the whole training set. Gradient descent runs in a loop. The number of iterations is determined by the number of epochs. This determines how long the computation is going to take. This can take quite long in some cases, especially if you have a lot of data. Now that you understand these concepts, I'm going to ask you to come to the final widget. Here you are going to play with gradient descent to get a better understanding of eta and the number of epochs.